Okay. Um, let me let me erase this part. Okay, oh, I got somebody else to admit. Okay, I don't like that I have to admit you guys in, but I guess that's fine. So Aiden couldn't do it. Are you guys able to see how to change your names? Excuse me. Change your screen names on there, or is that something I have to do every time? Whatever. I see you guys are raring to go to Talkaway today, huh? Okay, so somebody asked about the attendance question for today. Google Meet sort of takes attendance for us, but WebEx and Zoom do not, as far as I know. So the whole reason I think what I'll do is I'll put the attendance question up there, basically just to make things easier for me. That's pretty much it. Rather than taking like 5 minutes at the beginning of the hour to go through and mark down who's here, not to mention if somebody accidentally sleeps in and it comes halfway through the hour, I might not even, although if I have to admit them, I would see them. Either way, I put the attendance question up so you guys just mark that you're here. It shouldn't be too horrible. It takes you 5 seconds. So that way, no matter which platform we're using. So the district basically gave us another option because they didn't want everything's like so dependent on Google Meet that if Google Meet went down, that we wouldn't be able to go for the day. I refuse to use WebEx. That's like the worst service possible. I don't know why, but it just doesn't work well. So I'll use Google Meet and Zoom. I'll basically use Zoom for this week, and then you guys can kind of tell me how it works. I'll see how it works from my end, and then you guys can let me know from your end. I don't know. We'll see. There's probably advantages and disadvantages. But we are done with Chapter 5, and we are moving on to the second half of Calc. And that's accumulation of change in Riemann sums. I've also heard it pronounced Riemann sums. Actually, let me back up. This is for today's topic. The second half of Calc is integral calculus. Let's see, AG. Okay, so integral calculus is basically just backwards from derivatives. I mean, that's pretty much it. Now, I have never taught it in the order that Khan Academy teaches it, but I'm willing to give it a try. So now that I mentioned Khan Academy, I just realized that I did not assign anything from Khan Academy yet, from this chapter. I will do that when I'm done teaching today. Here, I'll go assign the stuff. But either way, both the AP and Khan Academy teach it in the same order. And so I'll just give it a try, see how it goes this year. I've never done it that order, but we'll find out. So the first thing we're going to talk about today is accumulation of change and Riemann sums. And let's see, I can probably move Google Meet out of the way so that I can see the Padlet. All right. So basically what we're going to start off, that's not a line. What we are going to start off with is kind of just talking about what they are. So let's just have a random function like that. And our goal, do such bad at drawing straight lines. Our goal is going to be to find the area underneath the curve from A to B. Oh, while I'm trying to make a mess of this drawing, you guys, I'm sure you definitely noticed that I didn't correct the test yet. And I basically told you guys ahead of time that I was going to shut my computer off for winter break and then not turn it back on until we came today. And that's exactly what I did. So just like you guys, I 100% needed a mental break. This year has been very difficult on teachers, especially teachers of difficult classes. So just the same as students. And I needed that time off too. So I will be correcting everything, shortly. But I didn't even remotely look at your tests. I didn't even look at a single email or message. So if you sent me one, don't think I'm ignoring you. I just did not look. Okay, so this is how we're going to start talking about integral calculus. Our goal is going to be to find the area that's shaded yellow. Okay. Now let me put. I don't know if I'll put labels on this yet or not. Sure. Let's pretend this is feet per second. This is seconds. Okay. Now this is kind of an irregular shape. Let's pretend it's a rectangle, right? Who should we go with? We'll go with Bella. Bella, let's pretend this is a rectangle instead of a curvy line. How would you go about finding the area of that rectangle? Yeah, perfect. Okay, so the length would be the number of seconds. The height, whatever we'll call this, this is probably length, width, whatever. The height in this case is feet per seconds. So if we did the number of seconds times feet per second, our answer would be total feet. So before we even go about how to find these answers, I wanted to make sure to talk about what the answer would stand for. So it's easy to say find the area that's shaded in yellow, but whether this is a standard regular shape or irregular, you're still going to kind of find the answer the same way. You're going to take this dimension times this dimension. And if I take feet per second times seconds, I would get feet. So in this particular case, if we had a velocity function, because this would be the labeling on velocity function, and we had a velocity function over time, the area would represent the total number of feet traveled, right? So this would be a variable velocity, the function. And then, so let's say this was from 3 seconds to 20 seconds. We could find out how many feet were traveled between 3 and 20 seconds. Even though it was changing velocities, this is how we would do it. Now, I kind of asked Bella how to find the answer if this was like a regular shape. And this is leading you ahead. So I said, I've never taught it this order, so I'm not used to teaching things this direction. I'll give you the symbol. So this is going to be the integral symbol. This symbol says what we are going to do it's really hard to draw thin rectangles. Sure, we'll go with that. If we want to figure out the area that's here, one thing we could do is basically draw a lot of these little rectangles, right? And we could find the area of each individual little rectangle and add them up. And each rectangle has a height of f of x. And each rectangle has a width by whatever you decide. Now, in our case, delta x is often the notation they use for the width of the rectangle. And that is either decided ahead of time or, you decide it type thing. But let's say we want 100 rectangles. Well, what I would do is I would take how far this is. It's a length of 17 divided by 100 rectangles, and then that would tell me the width of each rectangle. Now what this symbol is here is this is the integrand symbol. And it represents that we are going to add up a bunch of rectangles. And the height of each rectangle is the function. The width of each rectangle is delta x. Now in calc, we actually usually don't notate delta as a d. Now you guys are used to seeing dx from the derivative, but it stands for delta. And so this symbol represents the fact that we are going to add up a bunch of these rectangles to estimate the area. And we are going to add up the rectangles starting with A and ending with B. This is traditionally what's referred to as an accumulation of change. No, that's not the word I used up top, is it? Yeah, change. And the reason they refer to it as accumulation is because you're adding up a bunch of things. Okay? Now, this is the calculus notation. I'm actually assuming have you guys ever seen this symbol? Have you guys ever used this in pre-calc or Algebra 2? Okay. Was it in pre-calc? Oh, okay. Okay. So this is the symbol that's normally used as, it's called summation notation. And the symbol stands for you adding up a bunch of things. This integrand symbol that I just wrote down is based off of this summation notation. And usually what you do is you start adding That's an N. So if, God dang, this is super hard to draw on a computer. So this is going to be my first rectangle. And this would be delta x1. My second rectangle would be delta x2. And so on and so on. Ugh. Until you get to your last rectangle, which I know I didn't put at the end. And the last rectangle would be delta x sub n. And so this notation would basically just mean that you're going to add up your rectangles from the first rectangle to the last one. So this is called summation notation. Now, if we want to get a super accurate answer for this yellow shaded area, the way we would do this is have like a billion rectangles. You know, if your rectangle is so ridiculously small that it doesn't even look like a rectangle, or thin I should say, then you're going to have a lot of them, and there would basically be an exact estimate. So what we do is we're going to be looking to do the limit as n approaches infinity for an infinite number of rectangles, taking the length and the width of each rectangle and then adding them up. So this notation is what leads us to this. Now, I fully get that this probably looks stupidly scary to you right now. Like I went from us starting off with a drawing to using like this crazy notation. And I'm just basically trying to introduce you to it now. We absolutely are not, I'm not expecting you to like be able to just do this, okay? I'm just kind of like showing you where some of this notation is coming from, and we're going to flat out just use it together, okay? So I'm hoping this isn't freaking you out. We haven't even started doing a problem yet. I just wanted to show you notation. So let me kind of introduce you to the types of problems we're going to do today, and just today. So let me kind of stick with my example that I did up there, where let's draw a graph that is feet per second by seconds. Yeah. I basically haven't talked for so long that my voice forgot all about how to talk. And that's not blue. It's not even remotely in the right spot. Oh, all right, you guys just need to use your imagination that I'm drawing a nice line. So this is the point 320. This is the point 520. And this is the point 60. So the types of question you would get from this would be, how many total feet traveled in the first 6 seconds? So this is kind of being based off of the question I did up above, where I was trying to find the area of the shaded portion. Well, that works for here too, okay? So if I want to find the total feet traveled in the first 6 seconds, well, if I take feet per second, and by seconds, that would give me feet. So this section right here would represent total feet traveled. Ariana, how about you? How would I go about finding that answer? Yes. It won't tell you that. Sorry, I cut you off. Yeah. Yeah, absolutely. You could do the area of a trapezoid. I will tell you guys, you don't have to. So if you wanted to just make it easy on yourself and split this up into 2 triangles and a rectangle, you absolutely could do that. A trapezoid 100% would work in just like one shot. But if you wanted to break it up into smaller, you could. So I'll do the trapezoid, because you guys actually will need to be doing trapezoids soon, which I don't even know if we'll get to it today, but I'm going to try. So trapezoid, area of a trapezoid. It's going to be 1/2 base 1 plus base 2 times height. So 1/2 base 1 plus base 2 just finds the average of the top and bottom. So for this particular example, base 1 is a length of 6. Base 2 is a length of 2. The height is, Jacob, what's the height? Yeah. It's going to be super easy to say like 4 or something, so just make sure you guys go by the scaling. So we got 1/2 of 8, which is 4 times 20. And so this would be 80 feet traveled. And we don't even know what the situation behind this one is. I'm sure something could tell you. But I wanted to go over how to find the answers. I don't even know what to... Do you guys have any kind of questions out of this? Like, does this even seem easy to you? Or does this seem overwhelming? I don't know. The integral, so that's why I said this is the first time I'm going to teach it in this order. We're not even going to do anything with the integral until, I think it's after quiz 3. Yeah, so I was giving you guys a preview of notation, but we don't even need to use it for today at all, because all of the shapes you're going to get today are just geometric. Okay, on this topic, Maybe if you guys could type something in the chat, like super, how do I even bring that up? How do I show the chat? More. Oh, there it is, chat. If you guys, oh, what happens if you get a shape that doesn't, oh, you're not going to get one yet, Chase. So we're leading up to irregular shapes. So for now, it's just easy formulas. How is this from the one topic so far? If you have a geometric shape, are you guys feel comfortable answering questions on these? That's what I was hoping you could kind of just type in the chat. Okay. It is very straightforward. I just didn't know how much you guys shut off your brain over break. So I didn't want to assume that this was going easy. All right. Now here's the next topic, similar style. We'll do one with an irregular shape. I'll try to make it so we'll just pretend this is very zoomed in. So if we want to estimate this area, because this is not a geometric shape, and so that's why I'm very much using the keyword estimates. Okay. If we want to estimate this area, one method that we can do are known as Riemann sums. And I have also heard it pronounced Riemann. I'm not going to pretend to know which one is correct. And Riemann sums is using geometric shapes to estimate area. So Riemann sums makes it sound pretty hefty or complicated. It is not. It is basically just using geometric shapes to estimate. Okay. Now let's say we'll start relatively basic. 2 shapes intervals. So if I'm going from 0 to 2, well, each interval would be a width of 1. And let's just start with the most basic shape, a rectangle. Why? What is wrong with you, computer? Why do you do that? Okay. Okay. So here I've drawn 2 rectangles. Kennedy. First question for you. Would this be Would this be like an underestimate, an overestimate? Yes, definitely. And that's because both of these rectangles are below the graph. And so you can definitely see that there's yellow shaded part that it doesn't even get. So this would be an estimate, and we'd call it an underestimate because it is clearly going to be less than the correct answer. Okay? Did you guys notice how I drew the rectangles? Oscar, how about you? Did you notice how I decided to draw the height of the rectangles? That was a perfect way of saying it. So when I drew the rectangles, I made the height of the rectangle from the left-hand side. And so the left-hand side of the rectangle, I made the same height as the function. When you use the left-hand side, this is known as a left endpoint estimation, because I decided that the left-hand side of the rectangle would be the height. And so the height of the function on the left-hand side of the interval decided it. And so in this case, this would have a height of 1. This would have a width of 1. My first rectangle would actually be a square, apparently. My second rectangle would have a height of 2, because if I plug 1 into f of x, it would be 2. And so my second rectangle would be 2. It would have a width of 1. And so my estimation would be 3. Using left endpoint. No, that's a good idea. You can't do that with Riemann sums. You can't do that, but that's definitely a good idea. So the idea for Riemann sums is that you just have the one shape and you kind of go with it and see what you get. Now, we do have other options. Is this going to let me change? Oh, thank God. We do have other options. This would be known as right endpoint, because the right-hand side of the interval would determine the height of the rectangle. The idea for Riemann sums is that you have to use the function height to find the answer. So you're basically only picking one shape in each interval. So like for this particular one, we're only doing 2 intervals. So whatever shape you have, there can only be one shape in each interval. I mean, you guys definitely are coming up with good ideas to find better estimates. So this is known as right endpoint because I used the right-hand side. And if I did right endpoint, my first rectangle, I'm going to use f of 1 because f of 1 is the right-hand side. And then the width is 1, so my first rectangle is now 2. For my second rectangle, I'm now going to use f of 2 because the right-hand side of my second interval is 2. So f of 2 is 5, a width of 1. And so what I get is I get 7. And clearly we know that this is an overestimate because we've got a bunch of the rectangle that's above the actual graph. Nope. I'm trying to take my time on this so that you can see what it looks like, because that's the biggest issue on this. Okay, now there's other ways to measure. So this is where to me it's just stupid, because there's so many options. And I say stupid, I mean it's not really stupid. We're leading up to something. But like these estimations are totally just like estimations anyway. Sam, how about you? What do you think I just did to determine the height of the rectangle just now? Yes. This is going to be called the midpoint estimation. What I did was I used the middle of the interval to determine the height. So this is called midpoint estimation. Now this one's actually traditionally better, because you can see that we have an overestimate and an underestimate in both sections. And so traditionally this midpoint one is closer to the correct answer. Now I got to actually calculate this though. F of 0.5 squared is 0.25. Yes, so we have 1.25 times the width of 1. 1.5 squared, 2.25, I believe, plus 1. 3.25. So 3.25 times the width of 1. So together this would make 4.5. Now, I don't know if you noticed this pattern down here. Conveniently, 4.5 is the average of 3 and 7. And so if you didn't want to calculate the middle point, you could calculate the left and the right, because they're usually easier, and then find their average. And that's going to be the same as midpoint. Okay, one last estimation, and then I will call it a day, because I think you guys... Well, you're probably like me. Your brain did not get worked at all over break, and so you're probably hurting right about now. The last estimation is to not use rectangles. Let's use trapezoids. I believe I can do it with this. So if I do a trapezoid, son of a gun, that did not work out as nice as I expected. All right. You know, Microsoft just like ruins some things. Just like in Microsoft Word, it drives me nuts that it wants to try to use accurate spots. Okay, so there's the first trapezoid. The second trapezoid would be from 1 to 2. That was I'm actually really impressed with that line that I just drew. Maybe not so much that one. So this has two trapezoids, and you're going to find the area of each trapezoid separately. Now, it is a trapezoid, but it's sideways. So, like, this is base 1, this is base 2, because the bases on trapezoids are the parallel sides. So to find the area of each trapezoid, it's going to be, I wrote it up top, but it's 1/2 base 1 plus base 2 times height. Height is how far it is between them. So at f of 0, the height was 1. F of 1, the height was 2. And then at f of 2, the height was 5. Okay, so my first trapezoid has an area of 1 plus 2 times the height between them, which is 1. So my answer is 3/2, or 1.5. My second trapezoid and 7/2, or 3.5. So using trapezoids, my estimation is for 5. If I could spell trapezoids. Okay, so today in Khan Academy, like the homework that I'd like you guys to try. The first couple questions are from just finding the area of geometric shapes. The second set of questions is just like this, where you will have a non-geometric shape that you're going to estimate using rectangles or trapezoids. And they're called the Riemann sums. Now, you might have more than 2 intervals. I just did 2 to make it easier on us to go quicker. You will be told how many intervals. The more intervals there are, the more accurate it is. Let's see, I think, I'll remind you guys again. 1, make sure you enter the attendance question so that I can get attendance entered into the computer. I think we'll just make that a daily thing again, just so it's easy to be in a habit of doing something. Because I don't want to have to look at the screen and do attendance that way. It seems dumb. I could, but I don't want to. In Khan Academy, I'm going to stop assigning the videos because some people were understanding that that was part of the assignment, and it's not. The videos are there if you get confused. I'm only worried about the assignments. So I'm just going to assign the assignments. The videos are there to help you out if you want extra help. I don't know. Anything else you guys have a question on? It was great to be back today, at least. Have a routine again. Oh, good question. I bet maybe I'll just do Zoom this week just to make it kind of uniform. Did you guys, after 1 hour of me trying to teach, does it seem any different than Google Meet, or is it basically exactly the same? That's kind of what I thought. So for some of you, it might still be choppy. For some of you, it's coming through fine. Okay. All right. Well, I guess I'm done today. I will go on Khan Academy right after this here and assign I'm going to assign the entire chapter at once with the due date of January 21st, which is the end of the trimester, because that's going to be Mr. Stouffer and I's goal is just to finish Chapter 6, Unit 6, for the whole end of the trimester. We just couldn't go at the same pace we were going before. It just wouldn't work, both for you guys and for us. So we will finish Unit 6 by January 21st. So that's the due date for all the assignments. All right, I'll stop the recording.